Hello friends, this is Sandeepan here. Welcome back to my YouTube channel. In the previous video, we have learned all about append and delete operation through file handling in Python along with some bonus topics with examples. Today, we are going to explore one of the most important topics in Python, that is errors and handling errors in Python in different ways with a lot of examples. Stay with me till the end because today's topic is going to be a really crucial one, and if you want to make sure that your code doesn't crash in unexpected ways while running, this tutorial will be a must watch for you. So, without any further ado, let's get started. So, let's start with understanding different types of errors we may encounter in Python. The first type of error is syntax error. So, syntax error occurs when the code violates the rules of Python syntax. In Python, there are some syntax rules which defines the way how we have to write our code. When our code violates these rules, then syntax error occur. Then comes runtime errors, also known as exceptions. Runtime errors occur during the execution of the program. At the time of program execution, if any unexpected situation comes and the program does not able to handle it, then it raises runtime error, and after that the program used to crash or terminate unexpectedly. So it's very important to handle this type of error to make sure that our program does not terminate or crash in such way. We will talk about the ways to handle errors in a minute. The last type of errors are logic errors. Logic error occurs when some faulty logic leads to incorrect result without crashing the program. It occurs when the program runs without crashing but produces incorrect result due to faulty logic. Now let's understand each type of errors in details with some examples. First, if we talk about syntax errors, they will look something like this. Here you can see I have removed the closing bracket from the print statement, and according to Python syntax rules, every bracket should be closed properly. So Python is notifying me with an error saying the bracket is not closed and showing with a red underline. So this type of errors we can easily identify before running the program, as these errors are identified in the program interpretation process. If you want to learn more about how a program actually executes through all the stages of interpretation, execution, etc., let me know in the comment section and I'll make a dedicated video for it. But for now, interpretation is basically a process of converting the source code into a machine understandable code. So this type of error can be predictable and cannot be handled via error handling techniques. Next type of error are runtime errors, also known as exceptions. As we discussed earlier, this type of errors are most unpredictable and can cause our program to crash unexpectedly. So handling this type of error are very important in our code. Let's understand with some examples. Let's declare two variables like this: num1 equals 10, num2 equals 0. Now, if we try to perform division between these two numbers like this, result equals num1 divided by num2. Print result. And run this program now. This is raising an runtime error, that is zero division error. So this is an example of runtime exception. In this example, we have directly assigned 0 to num2 variable to raise the exception knowingly. But imagine a scenario where we are taking this value from user input and unknowingly the user enters value as 0. And as we don't have any control on user input, our program may crash in such unexpected ways with runtime errors. That's why we always should implement error handling techniques by predicting what all runtime errors can occur with our code. So let's see how we can handle these errors. The first technique of handling these errors is using try except block. The syntax will look like this: try, colon, then the code that may raise an error, and then except, the error type we have to mention, and then inside that the code to handle the error. Here the code inside the try block will execute. If an error occurs, Python will look for a matching except block. If a matching except block is found, the code inside it will be executed. Let's implement the same in our code. So first, we need to write a try except block. Then have to put the main code inside the try block like this. And then we can write the code that will execute if any runtime exception raises inside the except block. For now, we can print some meaningful message like this. Some error occurred. And now, if we run this program, you can see it is not terminating unexpectedly anymore. Rather, it is showing a meaningful message. This way, we can perform any alternative operation if such error occurs. Let's see another way of handling errors. Instead of defining a generic exception block, we can also define a specific exceptions by defining the exception name after the except keyword like this. Except zero division error. This way we can handle the error in a more specific way. In a program, multiple types of errors can raise. For example, here instead of assigning value directly to num1 and num2, if we take it from user input like this, int, inside input, inside enter a number, num2, int, input, enter another number, and run the program, and mistakenly, if I enters a letter like a instead of a number, you can see it raises a value error as it cannot be converted into an integer. So in this case, zero division error will not be able to handle this error. So in this situation, we can define multiple except block with specific types to handle multiple specific errors. For example, if I define a except block with value error with a meaningful message like this, please enter a valid number and try again and run it. This time, if we enter A as input, you can see it is showing a message, please enter a valid number and try again. So this way, we can handle multiple error types with respect to one try block. We can also use a finally block after the except block to execute code regardless of whether an error occurred or not. We can add a finally block after the except block like this. Finally, then print program ends correctly. So this block will always execute at the end of the program. If we run this and enters a wrong value like this, you can see it is executing the value error block as well as the finally block. If we enters the correct value also, it is showing the result as well as the finally block code. One practical use cases of finally block we can see in the file operation. After opening the file, it's very important to close the file regardless of whether our file operation is successful or not. So in this scenario, we can do our file operation like this. File equals open. Inside, you have to give the path, then file.write hello. Here, if you notice carefully, you can see we are trying to open the file in read mode, but then trying to write the text hello. If we complete our code without error handling like this, file.close, you can see it's throwing unsupported operation exception. So we can wrap the code in try except block like this. As the unsupported operation is not there in the list of errors, we can handle it in a generic way like this, except, then print unsupported operation. And now, even if this error occurred, still our file is in open state. Anyway, we have to close the file, otherwise it can cause unexpected errors with the file in our system. So we can add a finally block to close the file like this. Now, if we run it, you can see it's throwing the error, but still our finally block executes and closes the file. We have already discussed about file operations in details in our previous videos. If you want to learn more about file handling in Python, you can check that out. Similarly, while doing any database operation or working with HTTP connections, it's very important to close the open connection regardless of whether our operation is successful or not. There also, we can use the finally block to do the same. Now here's a bonus point. We can also raise errors explicitly from our code. There comes custom exceptions. But why do we need to raise errors like that? Sometimes we may want to raise our own exceptions to indicate specific errors in our code so that we can handle it in our way. We can do this using the raise keyword. For example, if we define a function to perform division between two numbers like this, def divide, taking x, y as arguments, and here we can raise an error if the value of y is given as 0 like this. If y equals 0, raise value error cannot divide by 0. So here we have to use the raise keyword, then error name, and then we can optionally pass a message as an argument. Then we can complete our function by returning the division like this, x divided by y. And now we can use this function inside a try except block like this, try, then result equals divide inside bracket 10, 0, except value error as e, print error e. Now here's another bonus point. Here we can use an alias with the error name, and using that alias we can print the error message also. Here we can handle the same using zero division error, but this was an example of how you can raise your custom error whenever you like and handle it in your way. The last type of errors are logical errors. Here's a simple example to show how logical errors occur. Def add underscore 5, taking num as argument, return num into 5. Result equals add 5 with 10, print result, result. So this is a logic error because the function should add 5 to the input number, not multiply it. One of the way to identify this type of logical errors is we have to run multiple test cases for the program and check whether it is giving the expected result or not. If it's not giving the expected result every time, then we need to debug or go through the code logic in order to correct it. We will learn more about debugging techniques in more details in our future videos. If you want to learn more about debugging techniques in Python, please let me know in the comment section below and I will make a dedicated video for that. So that covers all about error handling in Python, but if you missed any of the points out, make sure to rewatch it and it will definitely be clear. But if you still have any doubt, feel free to comment down below. Hope you find this video helpful. If so, give a thumbs up, share the video with your friends, and if you haven't subscribed yet, subscribe to my YouTube channel so that I can create more such helpful contents like this. Hope to see you in my next videos. Till then, goodbye.